All right, let's recap the lesson. So today we're talking about parabolas, but in a different form. Yesterday we talked about parabolas in vertex form. So real quick, vertex form, right? And they have this parentheses quantity squared. That's vertex form. But today we're going to talk about parabolas in what we call root form. So they're a little slightly different. You don't see the quantity squared, you see parentheses, okay? So parabolas in root form. The roots turn out to be the x-intercepts. We're going to see. So here's our general formula, or main formula for root form. F of x, which same thing as y, is equal to a. And of course, if a is positive, you get a smiley face, opens up. A is negative, it's going to be a frowny face, opens down. But here's what we want to look at. Parentheses, x minus or plus some number, x minus plus some number. So this is our form for anything in root form. Because of the minuses, in math we know that minuses mean opposite, okay? All right, so then the roots would just be whatever this number is and whatever this number happens to be. Now roots are also x-intercepts, okay? Oh, we talked about a being greater than 0, opens up, a being less than 0, negative, frowny face opens down, okay? So we looked at an example, okay? And the example we did, come on in, Mr. Bard, I'm just recording. So the example we did had to do with x minus 3, parentheses, x plus 5. So you see the double parentheses. It's not vertex form because you don't see the quantity squared. It's different. It's parentheses, parentheses. So it's in root form. Well, what do we know? We take the opposite, So instead of a negative 3, we get a root at positive 3. Instead of a positive 5, remember, take the opposite, we get a negative 5. So these are my roots. They're also x-intercepts. Okay, so they're also x-intercepts. So the x-intercepts would be then 3, 0 and negative 5, 0. Okay, so I graph those. I have a point, an x-intercept at negative 5, 0. I have a point or an x-intercept at 3, 0. Okay, those are my two roots or x-intercepts. Now I know the line of symmetry is in the middle. So I could visualize where the middle is, and it's right there at negative 1. Or if I'm not sure how to do it, then to find the line of symmetry, I just add the roots and divide by 2. So I can't quite figure out what it is. You just add the roots and divide by 2. It's an average. So I went negative 3 plus a negative 5 divided by 2. I get negative 2 over 2, I get a negative 1. So I know, just like at C, that the line of symmetry is at x equals negative 1, right in the middle. That makes sense. Line of symmetry has to go through that middle. Now the vertex is on that, somewhere on there. I'm not sure where, so I do know the x value of this point. The x value of this point is negative 1. I know the x value of this point is negative 1. So I take my negative 1 as an x value, and I want its y. I've got the x value of negative 1, I want its y value, so I plug in the negative 1 for x into the original question. And I did that. I plugged it in, negative 1 for x, negative 1 for x, so I got a negative 1 minus 3. I got a negative 1 plus 5. I get a negative 4 times a positive 4. Gives me a y value of negative 16. Therefore, my vertex is at my point 0, negative 16. So there's my vertex is at, negative 1, negative 16 is my vertex. Okay. So now I have my line of symmetry. Now what about the y-intercept? Sure looks like I'm not sure what it is, but if I can find the y-intercept by doing this, along the y-axis, the value of x is 0. So if I let x be 0, so I want to find the y-intercept, I just plug 0 into the equation. So if I want to find the y-intercept, plug 0 in for x. I did that. 0 minus 3, 0 plus 5, I get a negative 15. So my y-intercept has to be at 0, negative 15. Okay, that's all I had. We had a worksheet. It was lesson 1-2. I believe it was right there. I needed you to go ahead and complete that for credit. Okay, I'll see you tomorrow. That's all I have.